Article 695.4 B2 Number 3 of the National Electrical Code requires that the disconnecting means for a fire pump not be located within equipment that feeds loads other than the fire pump. When retrofitting a substation with two 13,800 volts to 2300 volts transformers, mains, associated breakers and load breaks with a tie, along with a 500 horsepower fire pump and other pump loads, the disconnecting means for the fire pump must not be located within the same transformer that feeds other loads, such as the pump loads. To comply with this requirement, you may need to add a separate busway or cable system to an auxiliary load break specifically for the fire pump. This would isolate the fire pump from other loads and ensure that the disconnecting means for the fire pump is not located within equipment that feeds other loads. A facility's on-site generating facility may qualify as an alternate source of power, which means that you can use the on-site generator to power the fire pump in the event of a power outage. The transformers must also comply with the requirements for fire pump transformers. Article 695.4 B2 addresses disconnecting means for fire pumps, focusing on ensuring reliability and safety. This section details specific requirements for the disconnecting means to enhance the operational integrity of the fire pump system. Firstly, the disconnecting means must be identified as suitable for use as service equipment. This requirement ensures that the disconnecting means is robust enough to handle the potential load and fault conditions associated with a fire pump. Service equipment is designed to withstand higher levels of stress and is generally more reliable than standard disconnecting means. Secondly, the disconnecting means must be lockable in the closed position. This feature is crucial for preventing accidental or unauthorized disconnection of the fire pump. In a fire emergency, it is imperative that the fire pump operates without interruption. Locking the disconnecting means ensures that it remains closed, providing a continuous power supply to the fire pump. Thirdly, the disconnecting means must not be located within equipment that feeds loads other than the fire pump. This requirement aims to isolate the fire pump circuit from other electrical loads, preventing a fault in another circuit from affecting the fire pump's operation. By ensuring that the fire pump has its own dedicated disconnecting means, the code minimizes the risk of a common point of failure. Fourthly, the disconnecting means must be located sufficiently remote from other building or other fire pump source disconnecting means such that an inadvertent contemporaneous operation would be unlikely. This provision is intended to prevent accidental simultaneous operation of multiple disconnecting means, which could lead to confusion or unintended system shutdowns. The location of the disconnecting means should be carefully considered to ensure that it is easily accessible for authorized personnel, but not easily accessible for unauthorized individuals. Additionally, the disconnecting means should be clearly labeled and identified to avoid confusion during an emergency. The selection of the disconnecting means should also take into account the specific requirements of the fire pump motor. The disconnecting means must be rated to handle the motor's full load current and locked rotor current. It is essential to consult the motor's nameplate and the relevant sections of the National Electrical Code to ensure that the disconnecting means is properly sized. Furthermore, the disconnecting means should be installed in accordance with the manufacturer's instructions and all applicable electrical codes and standards. Proper installation is critical for ensuring the reliability and safety of the fire pump system. Regular inspection and maintenance of the disconnecting means are also essential. The disconnecting means should be checked periodically to ensure that it is in good working condition and that all connections are tight. Any signs of damage or corrosion should be addressed promptly. In summary, Article 695.4 B2 provides detailed requirements for the disconnecting means of fire pumps, focusing on ensuring reliability, safety, and operational integrity. By adhering to these requirements, electrical engineers and installers can help ensure that fire pumps operate effectively during emergencies, protecting lives and property. Article 695.3 addresses the power source requirements for fire pumps, particularly in facilities with on-site power generation. This section outlines the conditions under which an on-site generator can serve as a reliable power source for a fire pump. Firstly, the on-site power source must be capable of providing power to the fire pump within the time specified in Article 695.3d. This ensures that the fire pump can start and operate quickly in the event of a power outage. The transfer time is critical because delays can compromise the firefighting capabilities of the system. Secondly, the on-site power source must have sufficient capacity to supply the fire pump along with all other essential loads. This requirement ensures that the fire pump will not be starved of power during an emergency. The capacity of the generator must be carefully calculated to account for the fire pump's full load current and locked rotor current, as well as the demands of other critical equipment. Thirdly, the on-site power source must be equipped with automatic transfer equipment that will switch the fire pump to the generator in the event of a utility power failure. This automatic transfer switch should be designed to operate reliably and quickly, minimizing the interruption of power to the fire pump. Fourthly, the on-site power source must be located in a room or enclosure that is protected from fire and other hazards. This requirement is intended to ensure that the generator will remain operational during a fire emergency. The room should be constructed of fire-resistant materials and equipped with appropriate fire suppression systems. Fifthly, the on-site power source must be tested regularly to ensure that it is in good working condition. These tests should include load tests to verify that the generator can supply the fire pump and other essential loads. The results of these tests should be documented and maintained for future reference. In addition to these requirements, the National Electrical Code also specifies the types of on-site power sources that are acceptable for fire pumps. These include generators driven by diesel engines, natural gas engines, or steam turbines. The selection of the appropriate power source will depend on the specific requirements of the facility and the availability of fuel. It is also important to consider the environmental impact of the on-site power source. Diesel generators, for example, can produce significant amounts of air pollution. Natural gas generators may be a more environmentally friendly option in some cases. In summary, Article 695.4 ATWO provides detailed requirements for the use of on-site power generation as a power source for fire pumps. By adhering to these requirements, electrical engineers and installers can help ensure that fire pumps operate reliably during emergencies, even in the event of a utility power failure. Article 695.5 focuses on transformers used to supply power to fire pumps, outlining specific requirements to ensure their reliability and performance. These transformers are critical components of the fire pump system, and their design and installation must meet stringent standards. Firstly, the transformer must be dedicated to the fire pump and other fire protection equipment. This means that the transformer should not supply power to any non-fire protection loads. This requirement helps to isolate the fire pump circuit from other electrical systems, reducing the risk of a fault in another circuit affecting the fire pump's operation. Secondly, the transformer must be sized to supply the fire pump motor's full load current and locked rotor current. This ensures that the transformer can handle the high current demands of the fire pump motor, especially during startup. The transformer's kilovolt amp rating should be carefully calculated to account for the fire pump motor's characteristics. Thirdly, the transformer must be protected against overload and short-circuit conditions. This protection should be provided by fuses or circuit breakers located on the primary and secondary sides of the transformer. The overcurrent protection devices should be sized to coordinate with the transformer's thermal overload capacity and the fire pump motor's protection devices. Fourthly, the transformer must be located in a room or enclosure that is protected from fire and other hazards. This requirement is intended to ensure that the transformer will remain operational during a fire emergency. The room should be constructed of fire-resistant materials and equipped with appropriate fire suppression systems. Fifthly, the transformer must be installed in accordance with the manufacturer's instructions and all applicable electrical codes and standards. Proper installation is critical for ensuring the reliability and safety of the fire pump system. In addition to these requirements, the National Electrical Code also specifies the types of transformers that are acceptable for fire pump applications. These include dry-type transformers and liquid-filled transformers. The selection of the appropriate transformer type will depend on the specific requirements of the facility and the availability of space. It is also important to consider the environmental impact of the transformer. Liquid-filled transformers, for example, can pose a risk of oil spills. Dry-type transformers may be a more environmentally friendly option in some cases. The code also requires that the transformer have a nameplate that clearly indicates its voltage, kilovolt amp rating, and other important characteristics. This information is essential for ensuring that the transformer is properly installed and maintained. Regular inspection and maintenance of the transformer are also essential. The transformer should be checked periodically to ensure that it is in good working condition and that all connections are tight. Any signs of damage or overheating should be addressed promptly. In summary, Article 695.4 provides detailed requirements for transformers used to supply power to fire pumps. By adhering to these requirements, electrical engineers and installers can help ensure that fire pumps operate reliably during emergencies. To elaborate on the selection of overcurrent protection for fire pump transformers, several factors must be considered to ensure both safety and reliability. Overcurrent protection devices, such as fuses and circuit breakers, are essential for protecting the transformer from damage due to overload and short-circuit conditions. Firstly, the overcurrent protection devices must be sized to coordinate with the transformer's thermal overload capacity. The transformer's thermal overload capacity is the amount of current that the transformer can withstand for a limited period of time without sustaining damage. The overcurrent protection devices should be sized to allow the transformer to operate at its rated capacity but to trip before the transformer is subjected to excessive thermal stress. Secondly, the overcurrent protection devices must be sized to coordinate with the fire pump motor's protection devices. The fire pump motor is typically protected by its own set of overcurrent protection devices, such as motor overload relays and instantaneous trip circuit breakers. The transformer's overcurrent protection devices should be sized to allow the motor to start and operate without tripping but to trip before the motor's protection devices if a fault occurs in the transformer. Thirdly, the overcurrent protection devices must be selected to provide adequate short-circuit protection. Short-circuit protection is intended to quickly interrupt the flow of current in the event of a short circuit, preventing damage to the transformer and other electrical equipment. The overcurrent protection devices should be sized to clear a short-circuit fault quickly and effectively. Fourthly, the overcurrent protection devices must be selected to meet the requirements of the National Electrical Code and other applicable standards. The National Electrical Code provides specific guidelines for the selection and installation of overcurrent protection devices, including requirements for interrupting rating, voltage rating, and coordination. In addition to these factors, it is also important to consider the type of overcurrent protection device to use. Fuses and circuit breakers each have their own advantages and disadvantages. Fuses are generally more reliable and provide better short-circuit protection, but they must be replaced after each operation. Circuit breakers can be reset after a trip, but they may not be as reliable as fuses. The selection of the appropriate overcurrent protection device will depend on the specific requirements of the application. It is also important to consider the location of the overcurrent protection devices. Overcurrent protection devices should be located on both the primary and secondary sides of the transformer. The primary side overcurrent protection devices are intended to protect the transformer from faults on the utility side of the transformer. The secondary side overcurrent protection devices are intended to protect the transformer from faults on the load side of the transformer. In summary, the selection of overcurrent protection for fire pump transformers is a critical aspect of fire pump system design. By carefully considering the factors outlined above, electrical engineers and installers can ensure that the transformer is adequately protected and that the fire pump system operates reliably during emergencies. Consider the implications of using an on-site generator as a redundant power source for the fire pump. This arrangement can significantly enhance the reliability of the fire pump system, particularly in situations where the utility power supply is prone to outages. However, several factors must be considered to ensure that the on-site generator system is properly designed and implemented. Firstly, the on-site generator must be capable of providing sufficient power to operate the fire pump under all expected operating conditions. This includes the fire pump's full load current, locked rotor current, and any other loads that may be connected to the generator. The generator's kilovolt amp rating should be carefully calculated to ensure that it can meet these demands. Secondly, the on-site generator must be equipped with an automatic transfer switch that will automatically switch the fire pump from the utility power supply to the generator in the event of a power outage. The automatic transfer switch should be designed to operate quickly and reliably, minimizing the interruption of power to the fire pump. Thirdly, the on-site generator must be regularly tested and maintained to ensure that it is in good working condition. Regular testing should include load tests to verify that the generator can supply the fire pump and other essential loads. Maintenance should include regular inspections, oil changes, and filter replacements. Fourthly, the on-site generator must be located in a secure and protected environment. The generator should be housed in a room or enclosure that is protected from fire, flooding, and other hazards. The room should be well ventilated and equipped with appropriate fire suppression systems. Fifthly, the on-site generator must comply with all applicable codes and standards. This includes the National Electrical Code, as well as any local or regional codes and standards. The generator should be installed and operated in accordance with these requirements. In addition to these factors, it is also important to consider the fuel supply for the on-site generator. The generator must have a reliable fuel supply that is sufficient to operate the fire pump for an extended period of time. The fuel supply should be stored in a secure and protected location. It is also important to consider the environmental impact of the on-site generator. Generators can produce significant amounts of air pollution, so it is important to select a generator that is as clean and efficient as possible. Consider using a generator that is powered by natural gas or propane, rather than diesel fuel. In summary, the use of an on-site generator as a redundant power source for the fire pump can significantly enhance the reliability of the fire pump system. By carefully considering the factors outlined above, electrical engineers and installers can ensure that the on-site generator system is properly designed and implemented. Furthermore, consider the implications of Article 695.4 B2 number 3, which stipulates that the disconnecting means for the fire pump must not be located within equipment that feeds loads other than the fire pump. This requirement is intended to isolate the fire pump circuit from other electrical systems, reducing the risk of a fault in another circuit affecting the fire pump's operation. In practical terms, this means that the disconnecting means for the fire pump must be located in its own separate enclosure or compartment, and it must not share any common wiring or components with other electrical circuits. The disconnecting means should be clearly labeled and identified to avoid confusion during an emergency. The disconnecting means should also be readily accessible to authorized personnel. In some cases, it may be necessary to install a separate busway or cable system to supply power to the fire pump. This can be a more expensive option, but it can provide a higher level of isolation and reliability. The busway or cable system should be sized to accommodate the fire pump's full load current and locked rotor current. The busway or cable system should also be protected against overload in short-circuit conditions. In addition to these requirements, it is also important to consider the location of the disconnecting means. The disconnecting means should be located as close as possible to the fire pump, but it should not be located in an area that is subject to flooding or other hazards. The disconnecting means should also be located in a well-lit area to facilitate operation and maintenance. Consider the coordination between the disconnecting means and other components of the fire pump system, such as the motor controller and the overcurrent protection devices. All of these components must be properly coordinated to ensure that the fire pump system operates safely and reliably. The motor controller should be designed to start and stop the fire pump smoothly and efficiently. The overcurrent protection devices should be sized to protect the motor controller and the fire pump motor from overload and short-circuit conditions. In summary, Article 695.4 B2 number 3 imposes a strict requirement for the isolation of the fire pump disconnecting means. By carefully considering the factors outlined above, electrical engineers and installers can ensure that this requirement is met and that the fire pump system operates safely and reliably. Remember the importance of proper labeling and documentation. Proper labeling and documentation are essential for the safe and efficient operation and maintenance of the fire pump system. All components of the fire pump system should be clearly labeled with their function, voltage, current rating, and other relevant information. The labeling should be durable and easy to read even in adverse conditions. In addition to labeling, it is also important to maintain accurate and up-to-date documentation for the fire pump system. The documentation should include a complete set of drawings, including single-line diagrams, wiring diagrams, and equipment layouts. The documentation should also include a detailed description of the fire pump system, including its operating characteristics, maintenance requirements, and troubleshooting procedures. The documentation should be stored in a secure and accessible location. The documentation should be reviewed and updated regularly to reflect any changes to the fire pump system. In addition to these general requirements, there are also some specific labeling and documentation requirements that apply to fire pump systems. For example, the disconnecting means for the fire pump must be clearly labeled to indicate that it is the disconnecting means for the fire pump. Fire pump controller must be labeled with its voltage, current rating, and other relevant information. The fire pump motor must be labeled with its horsepower, voltage, current rating, and other relevant information. The fire pump system documentation must include a copy of the fire pump system acceptance test report. The fire pump system documentation must also include a copy of the fire pump system maintenance records. Proper labeling and documentation are essential for ensuring that the fire pump system is properly installed, operated, and maintained. By taking the time to properly label and document the fire pump system, you can help to ensure that it will operate safely and reliably in the event of a fire. You have an on-site generating facility, which may qualify as an alternate source of power. Your transformers comply with the requirements for fire pump transformers. To comply with National Electrical Code Article 695.4 B2 number 3, adding a separate busway or cable system to an auxiliary load break for the fire pump ensures that the fire pump's disconnecting means is not located within equipment that feeds other loads.